Monica?
Yes, absolutely.
Okay. Okay, greetings, engineers. Welcome to this webinar on efficient analysis, design, and detailing using structural enterprise. Approximately, I'll consume around 45 minutes for this presentation, followed by a question and answer session. So the agenda for today's presentation is first I'll explain about structural enterprise and the project types covered by the structural enterprise. And then we'll look at some sample industrial project workflow, sample infrastructure projects workflow, and building projects workflow. So three different workflows using the same license. And then I'll explain about this new structural enterprise hub, followed by ISM, integrated structure model, followed by question and answer session. So this will be the short agenda for today's presentation. First, what is structural enterprise? Structural enterprise is not a product. It is a special bundle license of around 9 products from STAAD and RAM brands. So it includes the following 9 products. STAAD.Pro Advanced, which is a general purpose structural analysis, design and detailing software. I added the detailing in this presentation because now STAAD.Pro is not just an analysis and design program, but also a detailing program for both steel and concrete. And the second product is STAAD.Viva, which is a bridge engineering automated vehicle application. The third program is STAAD Foundation Advanced for foundation analysis, design, and detailing. And the fourth one is RCDC FE. This reads the file from STAAD.Pro, which is modeled as finite elements in STAAD.Pro. For example, a mat foundation module, which is analyzed in STAAD.Pro, can be read in RCDC FE, and we can then proceed with design and detailing. Okay, the fifth product is RAM structural system, which is a specialized product for building structural analysis and design. And the sixth product is RAM concept for slab and mat foundation analysis and design, including post-tension design. The seventh product is RAM connection, which is a steel connection design and detailing program. The eighth product is RAM elements for component design and detailing. And the ninth final program is microstrand advanced for general purpose structural analysis and design. The first program and the last program, STAAD.Pro Advanced and microstrand advanced, both are general purpose structural analysis and design program. But microstrand is used widely in the Australian, New Zealand market, whereas STAAD.Pro is used everywhere in the world. The basic difference between the first program and the last program, STAAD.Pro and microstrand, is that STAAD.Pro is a general purpose structural analysis program that not only does frame analysis but also finite element analysis, whereas microstrand does only frame analysis. It doesn't have the capability to model plate elements on solid elements, which STAAD.Pro does. And also, STAAD.Pro has many other advanced analysis features as well as detailing features. Okay, so this structural enterprise license bundles all these 9 products and give a special license. Okay, that is what structural enterprise license is. So if you are a user of any one of these products, if you are a user of microstrand or STAAD.Pro, you can upgrade to structural enterprise so that you can enjoy the benefit of all the 9 programs. Something like Microsoft Office, which is a bundle of Excel, PowerPoint, MS. Structural enterprise is a bundle of these 9 products, which includes general purpose structural analysis product, as well as special purpose building analysis product, as well as connection design program, and then slab design program, foundation design program, etc. Coming to the design code, support of design codes, STAAD.Pro Advanced supports almost all the international codes, 90 plus steel and concrete design codes included for free. That includes the Eurocode with Singapore and Malaysia National Annex for both steel and concrete. Also has the Australian Steel Code and New Zealand Steel Code. Okay, and STAAD.Pro has the American, British, and Indian bridge load codes. STAAD.Pro is the add-on module for STAAD.Pro, but now it is included in Structural Enterprise. It's useful for those users who use STAAD.Pro for bridge analysis and design. So this BIVA calculates the bridge loading based on American, British, and Indian codes only. And then we have STAAD Foundation Advanced, which supports all the international codes. US, Euro, British, Australian, Indian, Chinese, and Canadian. Our CDC is a design and detailing program for mat foundations as well as slabs that are modeled in STAAD.Pro as finite elements. It currently has only American and Indian codes. RAM Structural System is a specialized program for building analysis and design, as I mentioned in the previous slide. It has all the international codes, including the US, Euro, and Australian. RAM Concept is a specialized program for slab design and mat foundation design. It has all the international codes, including Euro, Australian, and US. RAM Connection, specialized connection design program, has the American, Euro, British, Australia, and New Zealand code also, including Indian code. RAM Elements has the American, British, and Australian codes. Basically, RAM Elements is a component design program similar to spreadsheet kind of program. Like you design a single retaining wall, single column, single beam, steel or concrete, single footing, single truss. So it's a toolkit kind of software. The Australian codes implemented in this program are available only for the steel modules, whereas the concrete modules are available for both US and British. Also steel. Okay. Microstrand is familiar in the Australian New Zealand market. It is having the British as well as Japanese codes also, in addition to the American code. Okay, so these are the design code supports. So now let's look into the project types covered by Structural Enterprise. Some companies specialize on doing industrial projects. Some companies specialize on doing building projects, but some companies does both. So this Structural Enterprise license suits the structural consulting company who does a mix of these projects. So industrial structures like power, process, mining, treatment, and nuclear plants can be modeled, analyzed, and designed. On the background, you can see a mining plant, a process plant in a mining industry. You can see there's structures that will be subjected to some vibration load, which can be analyzed and designed in STAAD.Pro. The foundations can be designed using the STAAD Foundation Advanced. The connections can be designed using RAM connection. And then general infrastructure structures like railway station, both elevated railway stations, underground railway stations, tunnels, stadium, etc., which are all called infrastructure structures, which can be analyzed in STAAD.Pro as well. And then commercial and residential building, like the one which I show on the right side, okay, which can be modeled, analyzed, designed in a RAM structural system and RAM concept, as well as our CDC program, as well as special structures. If the structure type is not covered under industrial or infrastructure or buildings, then we can call it as special structures, which can also be designed using STAAD.Pro, which is included in Structural Enterprise. So those are the projects that is covered by this special bundle license Structural Enterprise. So let's look at some sample workflow for industrial structures. So here's the typical workflow which I would suggest for this kind of industrial structures. For analysis and design of the steel structures, we can use STAAD.Pro for any international codes. And for producing a general arrangement drawing, we can use this new steel Autodrafter feature in STAAD.Pro to produce the design drawings. Notice that this is a new feature in the latest version of STAAD.Pro, Steel Autodrafter, which is useful to produce the design drawings directly from STAAD.Pro without any add-on. and you can save these drawings in a DXF file also. And notice that this is not a complete detailed drawing, but just the design drawing, general arrangement drawing only. It won't have the connection details. But then we have this RAM connection program, which is integrated inside STAAD.Pro, even though it's licensed separately. It's part of structural enterprise anyway. So this module can be useful for connection design and detailing. And foundations can be designed using STAAD Foundation Advanced, and which can also be launched directly from STAAD.Pro to read the support reactions from the superstructure and proceed with design and detailing of foundations. Any type of foundations like isolated footing or combined footing or pile cap or mat foundation. And finally, if your industrial structure contains some concrete elements such as beam, column, slabs, foundations, we can use this program, Advanced Concrete Design, otherwise called as RCDC. This feature is now available in STAAD.Pro, STAAD.Pro Advanced license to design and detail the concrete structures. Okay. All these modules, all these programs, STAAD.Pro, Steel Autodraft, RAM Connection, STAAD Foundation Advanced, RCDC, it's all included in Structural Enterprise. And by combining all these products, we can quickly finish the modeling, analysis, design, and detailing of any kind of industrial structures. So here, a small example I have. This is a steel structure supporting some piping and equipment. I have modeled it in fact, this was imported from a plant modeling software, Bentley Open Plant. So the plant modelers model the structure, equipment, piping in Open Plant, and they gave me this structure model through ISM. Later on, I'll explain about this. ISM is a file format using which we can import as well as export to various structural as well as plant as well as BIM programs. Okay, so using this ISM file, I imported this model from Open Plant, Bentley Open Plant. Okay, and then the piping from Open Plant was exported through a PXF file to our Bentley AutoPipe program. So the pipe stress analysis was done in Bentley AutoPipe. The structural analysis of the supporting structure was done in STAAD.Pro. So after the preliminary design of the steel structure, we import the piping model from Bentley AutoPipe. So here you can see the piping model imported from Bentley AutoPipe using this piping option in STAAD.Pro. We use this transfer loading feature to transfer the pipe support reactions into STAAD.Pro. So that way the structural engineer can save a lot of time in not referring to the piping isometric drawings with support reactions, hand mock support reactions, and manually transfer them into the structure. By using this piping workflow inside STAAD.Pro, we can import the piping model and transfer the loadings. Note that only the loads are transferred from piping to STAAD.Pro automatically, but the stiffness of the piping is not considered in this analysis in STAAD.Pro. So the piping what you view here is just for visibility only. And these are the anchor points in the piping, which is actually connecting to a pressure vessel. So we use the master slave command in STAAD.Pro to model the rigid link between the anchor point of the piping to the structure. So the loads will get transferred from this master joint to this slave joints. You can see these dotted lines. These are the piping supports. So this piping support will sit on this structural beam. And here we have a hanger. Here also, no, here it sits directly on the beam. Okay. So by utilizing this piping workflow, I transfer the pipe support reactions very easily into STAAD.Pro. And you can see here this load number 4, 5, 6, 7, 8. All these loads are coming in from the pipe stress analysis software. Okay. The other load cases, static load cases, I created it before in STAAD.Pro, and the load combinations I have done it in STAAD.Pro. Automatic load combinations for both steel as well as concrete. So I have two set of combinations. One is used for the structural steel design, and another one is used for the foundation design. Okay, so after we finish the analysis, we can view the unity check ratio, and in the output file, we can see the results. Okay. Remember, it's passing, and finally the steel takeoff. So after we finish the structural analysis, including the piping load, we now go to the steel Autodraft module. It's not a module actually, it is a free new feature in STAAD.Pro. Okay. So once we click this steel Autodraft, you can see the menu on the top got changed. We can fully customize the grids. The grids are automatically created alphanumeric grids, but you can completely customize it. And just select any beam and right mouse button click draw plan or section, and choose the scale and choose part section or full section and click the draw, and your drawing is ready. And notice the steel marking. These markings you can fully customize it. Notice the grids and the dimensions in the grids. All these are automatically drawn. And notice the buttons on the top left. You can directly open MicroStation from here. So this drawing can be directly open MicroStation if you are a user of Bentley MicroStation. Otherwise, you can just hit the save button to save this drawing as a DXF file so that you can use it in any CAD program. So this includes this section marking and schedule of the sections, material takeoff, approximate material takeoff, because the model is a centerline model. So now that we have created a plan drawing, now let's draw a section drawing looking at this point. So here's your section drawing, elevation drawing. Let's create some more section drawings. So now we have created 3 drawings in a matter of seconds, and we can save them as a DXF file. So now we can see that the design drawings can be directly generated from a structural analysis software, STAAD.Pro. And we don't need to use a separate CAD program to produce these general arrangement drawings. Now that we finished analyzing it and producing the design drawings, now we can go to the connection design module, which invokes the RAM connection. And you can notice on the right side, I have designed some 5 connections. And these symbols on the model looks like a gusset plate, shows that a connection has been assigned to this. Okay. So by utilizing the connection design program inside STAAD.Pro, we can quickly design and detail the connection. Whether it's a welded connection or a bolted connection, you can design. And notice the loads. The loads are automatically imported from STAAD.Pro to this connection design program. Okay, so this saves a lot of time for the structure connections. And the recent version of STAAD.Pro and RAM connection contains the latest Australian code as well as the New Zealand code. So here you can see the detailed drawings also produced, which can be saved as a DXF file, and you can extract the calculation sheet, including the formula showing step-by-step calculations. We can export this to MS Word also. I open up another connection just by double clicking on the spreadsheet on the right side. Now you can see a bolted connection, a beam column hinge connection, which is a moment connection. And here you can see the bill of materials. Okay, so that shows the connection design. Now finally, quickly we go for foundation design. Okay, so first we did the modeling in STAAD.Pro. Actually, I didn't do the modeling. I imported directly from OpenPlant, and then I imported the piping loading using this piping workflow, and then I finished the analysis and did the post-processing. After that, I produced the design drawing using steel Autodraft. I designed the connection using this connection design module, which invokes RAM connection. And now we are going to the foundation design. I'm going to launch this STAAD Foundation Advanced program directly from STAAD.Pro. So the advantage for this interoperability is that we are not using different programs to do different things. We can just simply export the member forces, the support reactions to the other program to design the connections as well as foundation. That makes the life of the structural engineer much easier. So now you can see that I launched directly the STAAD Foundation Advanced directly from STAAD.Pro. And you can see the program reads the results of STAAD.Pro support reactions as well as the column locations. And the support reactions are applied here as loads in this foundation design program. And you can create a job and select the code and choose any type of foundation. So I already created a isolated footing job here. I hit the design button. You can specify the soil parameters and the reinforcement parameters. And you can see the calculation sheet here. For this example, I used the ACA code, but you can use any code like Australian code or Euro code. And the calculation sheet shows all the step-by-step calculations, which is basically an XML file which you can copy and paste in any MS Word or Excel. And this GA drawing button shows the general alignment drawing with the grids and the dimensions. We have some primitive tools here to increase the font size. Some basic options here to change this northing angle. Okay, and we can save this GA drawing as a DWG file or DXF file. We can also produce detailed drawing for every footing. That shows the reinforcement information also. Plan view, section view. So each footing has a separate sheet. Here's the reinforcement information. We also have the design details in the bottom spreadsheet. In this example, I have not modeled the pedestal, but this program is even capable of designing the pedestal also if you have specified the pedestal details after importing in this foundation plan option. So apart from detailed drawing, we can also view the schedule drawing as well. So calculation sheet can be fully customized. On the right side, you can see the options to customize the report. Okay, so that small workflow explained how we can use the structural enterprise to quickly finish the modeling, analysis, design, and detailing of your superstructure as well as your foundation, including the connection. So out of this five workflows, I have showed demonstrated this first four workflow, and since this structure is not having any concrete, I couldn't able to show this last RCDC software, but I'll show that in the building workflow. Okay. Before building workflow, let's go for the infrastructure projects, otherwise called general projects. So for infrastructure structures, we can use STAAD.Pro for modeling, analysis, design, and detailing. For example, a tunnel, underground tunnel, we need to model it using plate elements. We can use the STAAD.Pro physical modeler for modeling these complex structures with intersecting surfaces. A single button click will automatically create the finite element mesh as well as stitch the intersecting meshes, which is a powerful feature of the STAAD.Pro physical modeler. Then use the STAAD.Pro change command to simulate approximate stage construction analysis. Very useful command. And use the 64-bit STAAD.Pro advanced solver for faster analysis. Use the 64-bit graphical user interface of STAAD.Pro for handling larger model and faster processing. The latest version of STAAD.Pro, the number of nodes doubled to nearly 450,000 nodes compared to the previous version, which was handling only 225,000 nodes. And use OpenSTAAD feature to create the geometry as well as to link your in-house developed spreadsheet with STAAD.Pro by writing macros using Visual Basic for applications and using the OpenSTAAD routines in those macros. Okay. So those who are interested in learning more about OpenSTAAD, there are many YouTube videos available. We also have LAN server videos, on-demand training material available in our LAN server. Just search for OpenSTAAD and you can get more information in YouTube as well as in our LAN server. Okay, so this is a typical workflow for infrastructure structures. So you can see for infrastructure structures, it's mainly the product used is STAAD.Pro. So here is a intersection of a tunnel, underground tunnel with a vertical shaft, which is also underground. And you can see the intersection is not that easy to model with the plate elements. But using the STAAD.Pro physical modeler, we can model the two cylinders, one horizontal, one vertical, and click a single button called analysis model on the right side top. That will automatically create the finite element mesh. Okay, not only the mesh, but also it stitches the mesh. So directly you can then go for analysis. Here you can see a stadium, a Hollywood stadium. This fully consists of steel structures. So STAAD.Pro is used for modeling, analysis, and design of this project. Another example is a underground railway station. This is Delhi Metro Station in India. Okay, this was completely modeled in STAAD.Pro, analyzed and post-processed in STAAD.Pro. When it was analyzed some 10 years back, it took around 22 hours to run the model because of the change command used by the user. But now with the STAAD.Pro advanced analysis, it reduced to nearly 20 minutes. Okay. So from 22 hours to 20 minutes. Okay, so let's go on to the building structure workflow. So for building structure workflow, you can see here I use completely different set of products, not STAAD.Pro, but RAM structural system to model, analyze, and design steel buildings, RAM connection to design the steel connections. Just like RAM connection is integrated with STAAD.Pro, it is also integrated with RAM structural system. If the building is concrete building, then I suggest to use RAM structure system to model and analyze only in RAM structure system and use this CDC program which is part of STAAD.Pro Advanced, which is again part of Structural Enterprise, to read the results of RAM structural system model, analysis results, and then proceed with design and detailing of my concrete building components. Okay, so beam design, column, slab, foundations can be designed in RCDC. And finally, RAM concept is useful for designing the slab as well as the mat foundation, both reinforced concrete as well as the post-tension slab. So for slab design, we have an overlap here. RCDC also does the slab design. RAM concept also does slab design. But in addition to slab design, RAM concept does mat foundation design also, which RCDC doesn't do. And RCDC doesn't support certain codes like Australian code and New Zealand code. It doesn't support, whereas RAM concept supports the Australian code. And RCDC is suitable for one-way and two-way slabs only, whereas RAM concept is suitable for even flat slabs as well as post-tension slabs with openings also. Okay. And long-term deflections calculations are can be done in RAM concept, whereas RCDC does not calculate the long-term deflections. Okay, so there are some overlap, but RCDC does many other things like beam design, column design, as well as detailing, bar bending schedule also, as well as estimation. Okay, so RAM structural system, RAM connection, RCDC, RAM concept. The combination of this, we can finish the building analysis, design, and detailing faster, whether it's a steel building or whether it's a concrete building. Generally, it's recommended to do the modeling in RAM structural system, except when the building is made of flat slab, where modeling in RAM concept is easier. Okay. Only when you have a flat slab workflow, I recommend the modeling beginning in RAM concept. Otherwise, I recommend the modeling in RAM structural system, like one-way flow or two-way flow or composite flow. We can proceed with the RAM structural system modeler. Or if the model is already done in a BIM program like Bentley Open Building Designer or Autodesk Revit, we can import that directly into RAM structural system using the ISM workflow. I'll explain that ISM workflow later. Two-way interoperability between RAM structural system and RAM concept makes life easier for the structural engineer, particularly when the slab is made of post-tension. So the post-tension forces on the slab will impact the column forces, so which needs to be updated in the 3D model in RAM structural system. So the two-way interoperability is very important for this workflow. Okay, so we'll look at a sample building project workflow for a 10-story concrete building. So I'll be using these two only, RAM structural system, RCDC, and RAM concept. So this is the 10-story building. Sorry for that. I don't want to use the audio. So I mute the volume. Okay, and then play it back. Okay. So this is a 10-story building, concrete building. I completely modeled it in RAM structure system, RAM modeler, from top to bottom, including the foundations, shear walls, slabs, everything. I modeled almost all the foundation types: isolated footing, pile caps, and mat foundation, as well as combined foundation for this sample. The mat foundation is for the lift core. Okay, so it is a 6 meter into 7, that is 42-meter length, and 5 into 5, 25-meter breadth. So 42-meter by 25-meter rectangle site, 10-story building. Okay, the red color beams and blue color beams, the differences. The red color members are lateral members, the blue color members are gravity members. So I have some gravity members which won't participate in the lateral load analysis. So we have this kind of flexibility in RAM structural system to model lateral and gravity members. So the modeling of this simple 10-story building took less than around 20 minutes to finish the modeling. I don't want to spend time here to demonstrate the modeling. If you're really interested to look at the modeling, I would suggest to look at my YouTube video. Just simply search concrete building analysis, design and detailing, and you'll get a YouTube video. If you still couldn't find it, just drop me an email. I can send you the link. Okay, so after we finish the modeling, we go to the RAM frame, and here we apply the lateral loads such as seismic load and wind loads. Since this is a specialized program for building analysis, all the codes are fully implemented. When I say all the codes, wind load code, live load reduction code, seismic code, load combination code, everything is fully implemented in this program. So applying the lateral loads is very easy. After we finish the analysis, we look at the post-processing such as displacement diagram. And we can animate it. The advantage of using RAM structure system for building structures is you model everything as a physical model, the slab as a slab, wall as a wall, and a single button click will automatically mesh the physical model into analytical model. We can also view the bending moment diagram and shear force diagrams. And then after we do the post-processing, we go to the RAM concrete module and run the RAM concrete gravity analysis to make the model ready for concrete design. And we also can view the vertical reactions floor by floor for the gravity loads. For each story, we can see the reactions. Okay, so now that we have finished the analysis in RAM structure system, now we can open up the RCDC program. And we can use the STAAD.Pro advanced license in RCDC to open up this program, because STAAD.Pro advanced is available in structural enterprise license, whereas RCDC is not included in structural enterprise. But because RCDC is part of STAAD.Pro advanced, we use the STAAD.Pro advanced license to open up RCDC as a standalone module, and here you can choose the design codes. So here you can see the Singapore as well as Malaysia National Annex for Eurocode. So this project I'm using Eurocode with the Singapore National Annex. So here we import the RAM structural system model. Notice that the same workflow can be used for importing the STAAD.Pro model also. So this RCDC program is our concrete design and detailing center for both STAAD as well as RAM. Currently, it does not have the Australian code yet, but in future, definitely will be implementing the Australian code. Currently, it has the Eurocode, American metric as well as imperial code, as well as the Indian code. So we can see now RCDC is importing the analysis results of RAM structure system, and I have chosen to design the column. Okay, similarly, you can design beam as well as isolated footing, pile cap, slab, staircase, etc. So here we have the columns as well as the walls imported from RAM structure system into RCDC program. And we click few buttons, specify some design parameters and reinforcement parameters. specify the minimum steel, maximum percentage of steel for column as well as shear wall, specify the minimum link spacing, maximum spacing, and the type of links, as hoops or ties. Okay, and the load cases. The load cases are all imported from RAM structure system. So we just need to specify the loading type in our CDC program, like this. And the load combinations are also imported from RAM structure system. But if you want to create the load combinations in this program itself, we have the templates available for various loads. We can do that. After we create the settings, after we finish the settings, just hit the auto design button, and then all the columns will be designed for all the load cases. We can watch the status at the bottom left side corner. Okay, so after the design is done, you can see the green color on the spreadsheet on the left side. So this shows the column as well as the wall detail, wall design. If there's any column that is failing, that will show as a red color, and we can use this reports failure diagnostics to view the reason for the failure. Okay, you can see that the column marking, the level, the size. The failure diagnostics is empty because there's no failed columns. Here you can see the capacity ratio for axial flexure, percentage of steel provided, main reinforcement, links, and if you design it for ductile detailing, you can see the ductile details, ductile links also. Now that many columns, we can group it. This is a very good command. I like it in the modify button. So this group command will automatically find out the columns of similar size and having similar reinforcement, and it will create the groups automatically. So now you can see the grouping is done. After the grouping is done, we can create reports such as a column text schedule. So here's the text schedule created in a blink of a second. We have both the non-ductile schedule as well as ductile schedule. So this one is a non-ductile schedule. Then we can pull out the detailed drawings. So within few seconds, we got this column detail drawing as well as the wall. So here's the column marking. Notice that we have done the grouping of the columns and walls, so the number of details are lesser. We can also pull out this column elevation detail drawings and wall elevation detail drawing. And this shows the laps also. The stock length of the bar is by default 12 meter. We can also pull out the design report. This is the design summary. So here's the column marking, the level, the size, material, and the governing load case, the axial and biaxial moments, percentage of steel, interaction ratio, main reinforcement, and links. And next, we can pull out the design calculations that shows a step-by-step calculation report. Including the code reference, the formulas, And finally, we can produce the bill of quantities report, including the cost estimation. We can choose the currency here and specify the rates, the unit rate as per the local practice, and the program multiplies the unit rate with the quantity and gives you the total cost in 3 different formats. This can be exported to MS Word or Excel, and then you can modify. So very quickly, we imported the analysis results from RAM structure system, and we produced so many reports: calculation report, design report, detailed report, detailed drawings, which can be exported to DXF. Now finally, the RAM concept program is used to import the math foundation results from RAM structure system. You can see this is the math foundation for the lift core, which we are importing in the RAM concept program. And now we are modeling the soil support, the soil subgrade modulus. The program will automatically calculate the spring supports based on this subgrade modulus we are entering. These are the grids which is imported from RAM structure system, and here we created the mesh, and now we create the design strips and perform the finite element analysis. And here's our results that shows okay. If not okay, we need to increase the thickness of the slab and redo the analysis. So this analysis is a iterative analysis because the spring supports generated are compression-only springs. Okay, and we can post-process and view this kind of deflection diagram and bearing pressure, soil bearing pressure diagram. If the soil bearing pressure is exceeding the allowable limits, then we need to increase the area of the mat foundation and redo the analysis. We can also plot the stress contours like this, and we can draw a line to cut the mat foundation, to draw a graph. Also, we can plot these reinforcement diagrams. We can completely delete the program design reinforcement and use, you can draw the reinforcement manually and redo the analysis to check the reinforcement provided by the user. So reinforcement is fully customizable. And after you customize the reinforcement, you can perform one more analysis to check the adequacy of the reinforcement. So these are the tools which allows for the user to draw their own reinforcement. And then in calculation option, you use this option called check capacity of user reinforcement without designing additional program reinforcement. So this way the user has total control on the reinforcement. And finally, we can go for a 3D walkthrough of the reinforcement cage. And then the estimation, cost estimation for the whole mat foundation. Okay, so by launching RAM concept from RAM structure system, the loadings on this shear wall are automatically imported into RAM concept, including the mat foundation that we have modeled in RAM structure system. So that speeds up the design. Okay, so now this short workflow, we used RAM structure system to do the modeling of this 10-story concrete building. As I said, it just take 20 minutes. If you really want to see the modeling, watch my YouTube video. And then apply the lateral loads, seismic loads, and wind load, perform the analysis, and do the load combinations, and then use our CDC program to design the columns, beams, shear walls, and use the RAM concept program to design the mat foundation, and use the RCDC program to design the isolated footing as well as pile cap. So that everything what you see here can be designed and detailed, not just analyzed. Okay. Now let's come to this Structural Enterprise Hub. What is this? Structural Enterprise Hub is a preferred method to discover, install, launch, and update products within the Structural Enterprise. So since Structural Enterprise itself is not a product, it is just a bundle of nearly 9 products. It's a special license. So users may get lost in which software to download. So instead of downloading all these 9 softwares one by one, you can just simply download this one program called Structural Enterprise Hub. And using this one program, you can install uh, from this one location. Once you finish the installation, you can launch this program directly using the Structural Enterprise Hub. And this Structural Enterprise Hub, once you install it, it stays in your taskbar. So you can just use your taskbar to open up this program and launch any program in Structural Enterprise. Whenever there is a new version available, this Structural Enterprise Hub shows you like this. More information on this is available in our community site, or simply search a Google search Structural Enterprise Hub. That will lead you to this link. Next, let's come to the ISM. ISM stands for Integrated Structural Model. So in Structural Enterprise, there are many programs available. You can communicate to all these programs through this ISM workflow, as well as to other programs like Bentley, EcoSim Building Designer, Pro Structures, or Autodesk Revit or Tekla, which also has plugin, ISM plugin. So using which ISM models can be imported as well as exported to all this software. And all these programs highlighted in red are included in Structural Enterprise. So that is a big picture. Okay. To put it simple, ISM is something like a DXF file, which many of us use to exchange the CAD information. But ISM, in addition to the CAD information, in addition to the geometrical information, it managed to store the structural information such as the section as well as material property. Okay, so that's what ISM is. But if you're an existing user of STAAD.Pro, you can upgrade it to Structural Enterprise or STAAD.Pro Advanced. And this is the chart that explains the feature difference between STAAD.Pro Advanced, and Structural Enterprise. This is a simple PDF file. You can search and get it from our website. If not, you please keep in touch with one of us. We can share this chart with you. So you can see Structural Enterprise basically has all these RAM modules: RAM concept, RAM connection, RAM elements, RAM structural system, as well as STAAD Foundation Advanced. Okay, so let's summarize what we have seen today. Structural Enterprise is not a product, but a special bundle license offering a single user license to access all the products in Structural Enterprise license. So if you buy one license of Structural Enterprise, you can launch all these 9 programs at the same time in one computer. Still, it will be consuming only one license. If you want to use it on another computer, then you need to close all these programs in the first computer and then open up in the second computer. So almost all types of structures varying from industrial infrastructure and high-rise buildings can be analyzed, designed, and detailed using Structural Enterprise license. The cost of Structural Enterprise is a fraction of the sum of the products it contains. Meaning, if you buy all these 9 products one by one as separate perpetual licenses, then that will be very expensive, maybe some $50,000 US. But when you buy the Structural Enterprise license, since it's a bundle license, this cost is only a fraction of the individual product cost, a fraction of the summation of the individual product cost. So that itself will be giving you approximately 75% discount. So that is the value of Structural Enterprise. Structural Enterprise Hub helps the user to install and update all the products so that the user don't need to go and search the installer of the 9 products one by one. Just this one hub helps the user to install all the products of Structural Enterprise.
Okay, thank you.
Yeah. Thank you.
Thank you, guys.